I am Phil Santonzi, Director of Client Engagement Services at Florida Makes. Florida Makes is the Florida member of the MEP National Network. MEP is the Manufacturing Extension Partnership, a program run out of the U.S. Department of Commerce and the National Institute of Standards and Technology. Our mission is to improve the productivity and technological performance of Florida's manufacturing sector. Our work and services for Florida manufacturers are driven by individual company needs. If you would like to know more about us, please check our website, as you see on the screen there, www.floridamakes.com. Today's topic is TRIZ, an approach to innovative problem solving, presented by Mr. Dan Sutter of Florida Makes. Today is January 24th, 2018. As a participant, your audio will be in listen-only mode using your phone or computer, whichever is more convenient. There's an opportunity to ask your questions using the question window. Please add your questions there throughout the presentation, and we will address those as time allows at the end. This is a live webinar event which will be recorded. A link to the recording will be provided to all attendees within a few days. I thank you for joining us. As we get started, I would like to present you with this brief poll question, please. We just want to get a sense of how many people are actually attending the webinar today. On multiple people on a single login. So if you could please click your response on the screen, and we'll take a few seconds for that. About another 10 seconds. Okay, Amanda, if you could please close the poll, and we'll see the responses. Okay, you can see the large majority of you are individually participating, and we welcome everyone. Okay, so now to our presenter. Dan Sutter is a Florida Makes business advisor working with the Manufacturers Association of Central Florida. As a trusted advisor within the MEP National Network, Dan has supported Florida manufacturers in implementing lean transformation, work simplification, ergonomics, and total quality culture throughout his career. He's trained as a Six Sigma Black Belt with over 30 years of manufacturing management and continuous improvement implementation experience, and he has earned a reputation for positive impacts on Florida manufacturing companies of all sizes. And with that, I would like to welcome Dan, and I'll turn this over to you, Dan.
Okay, thanks, Phil. Thank you very much for that, and welcome everybody out there. Today's webinar is on TRIZ, and as you can see the top line there, I'm unable to pronounce that. That's in Russian, but TRIZ is an acronym, and TRIZ translates into English as the theory of inventive problem solving. TRIZ is a problem solving methodology based on logic, data, and research, not intuition. Okay, it draws from past knowledge and ingenuity of many thousands of engineers to accelerate the project team or individual's ability to solve problems creatively. Once you get the hang of this, it's a lot of fun. Next slide is Genrikh Altshuller. He is the inventor of TRIZ, and he was a Soviet engineer, an inventor, a scientist, a journalist, writer, but most notable for his theory of inventive problem solving, better known today as TRIZ. He died in 1998. What he did was he screened at the time over 2,000 patents looking for inventive problems and how they were solved. And of these, again, that number is still growing today, over 1.5 million of them by folks who have picked up on this. But of these, he realized that only 10,000 or 5% in that day had somewhat inventive solutions. The rest were just straightforward improvements to something that was already out there. He more clearly defined an inventive problem as one with a solution that causes another to appear, such as increasing the strength of a metal plate will likely cause it to get heavier. So there's a trade-off. So in his study of patents, he found that many described a solution that either eliminated or resolved the contradiction with no trade-off. Worded another way, what is it that we really want, but not at the expense of? For example, do we want it heavier? Do we want it stronger, but we don't want it heavier? And here's a chart, kind of a breakdown, where he discovered that 95% of all of the patents out there were really just improvements on things. And what he learned was, if you have a problem or you have an issue, there may already be a solution for you out there from either personal knowledge, knowledge within your company, or knowledge within your industry, and even possibly knowledge beyond your industry. Somebody may have encountered a similar problem, and there may already be a solution out there that can help you. The founding principles of TRIZ is he hoped to develop a systematic step-by-step procedure. He realized for innovation, there really was no system, there was no process, there was no roadmap, if you will. He wanted it to be a guide through a broad solution space and focus down into an ideal solution. His goal was to make it repeatable and reliable and not dependent on physiological tools. He wanted to be able to access a body of inventive knowledge and then also be able to add to that body of inventive knowledge. And that's the database of the patents that he researched. And he wanted it to be familiar enough to inventors by following the general approach to problem solving. So this is the TRIZ model, okay? First of all, step one is when you have a problem or you have a challenge that you're trying to improve, either a product or a process. And we're going to go through a couple of examples of this. From there, you formulate your conflict statement. What is it that you want to improve, but not at the expense of? Okay. Then we're going to align the conflict statement with the 39 conflicting features matrix. And I'll show you that in the next slide. And what this features matrix is going to do, it's going to point you to 3 or 4 of the 40 inventive principles that he discovered in the patent study. And of those 3 or 4 examples, that's where you have to put on your detective hat, and hopefully within those you'll have a solution to your issue. Okay, so in the reality, your problem converts into a statement of conflict. We'll align it with the features, go to the matrix. It's going to point you to 3 or 4 possible inventive principles to consider, and hopefully you'll have a solution, or it will lead you to a solution. We're going to take a simple problem here first, just to kind of demonstrate how it works, okay? And I'm going to go through the manual way of using TRIZ. I'd like you to see that. And later on in the webinar, we're going to get into a more automated, faster way. Okay, so the first here is sometimes you have a can available to pour, but not the funnel. All of us have probably at one time or two tried to pour something and we didn't have the appropriate funnel, and maybe we ended up spilling it. So in this situation, a problem statement might look like we want to improve the pouring capabilities without compromising the ease of use. This can be worded a couple of different ways depending on what information source on TRIZ you're looking at. Sometimes it's phrased what we want, but not at the expense of, and sometimes it's phrased the feature to improve and then the feature to preserve. So in this example, we want to improve the pouring capabilities without compromising the ease of use. That's our statement of conflict, and now we're going to shift over to the 39 features of conflict, and we're going to try to align that problem statement as closely as we can with 2 of the 39 features of conflict. You don't want to get too tangled up in this step of the process because different combinations, there can be more than one combination here. What I've picked in the interest of time is we want to improve the device complexity of the can, but we don't want to compromise its ease of operation. Again, there are more than one way to look at a problem or an issue, so you can play around with this and pick more than one combination. But that happens to be what I felt like was the best one to fit. Somebody else may have a different opinion or a different way to look at the problem. So we're going to look at device complexity and ease of operations. And from here, it's going to point us to a couple of clues from the 40 principles, the 40 inventive principles. Now, I'm going to warn you, this next chart is quite a blur. There's a lot of data on it. And on this matrix, this is the TRIZ matrix here. In the left column these are the 39 features of conflict that we're hoping to improve. And coming across the top are the 39 features of conflict that we don't want to compromise. All right. I'm going to focus in a little here and see when we go down to device complexity like I picked and we scroll over to ease of operation, it points us to 4 inventive principles to look at. Here's where our solution might lie. In number 27, number 9, number 26, and number 24. Okay. So the next slide shows the 40 inventive principles. Again, this comes from the database of all of the patents, and I've circled the 4 that it is suggesting we look at. These 40 inventive principles are in the handout here for this webinar. And when you drill down into the detail of each one of these, you can see that it has a title. Number 9 is the first one we looked at, preliminary anti-action. And then it gives you some examples of what exactly the clues that it's pointing you to. If it will be necessary to do an action with both harmful and useful effects, this action should be replaced with anti-actions to control harmful effects. And then it gives you a sample, buffer a solution to prevent harm from extremes of pH. Or another example, create beforehand stresses in an object that will oppose known undesirable working stresses later on. Pre-stress rebar before pouring concrete, or heat treat it. Okay. Now, I'm not going to read through all 40 inventive principles. I'm only going to focus for now on the 4 that it pointed me to. And in the interest of time, I'm going to go from number 9. I didn't see anything in there in our gas can example that really jumped out at me or looked like a viable clue. So I'm going to shift to the next one. And the next one was principle 24, intermediary. And I looked deeper into intermediary, and I've got my Sherlock Holmes detective hat on that says use an intermediary carrier or intermediary process. And the example it gives is a carpenter's nail set used between the hammer and the nail, or merge one object temporarily with another, which can be easily removed. And the example it gives you here is a pot holder to carry hot dishes to the table. Merge one object temporarily with another, which can be easily removed. I put a star beside this one because that's where that looked to be the best clue on how to solve this problem. Of course, we have the next two was copying, and in the interest of time, I'm not going to read through all of those, but I didn't see a clue in there that might point me to a solution. Again, all 40 of these are in the handout. And then the last one it pointed us to was principle number 27, cheap, short-living objects. And again, I didn't star anything here because I didn't see the clue. I really got the clue from number 24, the intermediary. So the solution came from merging the gas cap with the funnel. And you can see this is a temporary thing that can go on and off. This also can be inverted to only serve as a cap. So that's kind of how the TRIZ process works. I'm going to walk through it again, the manual process one more time, and then we're going to go on to the more modern automated way. So this is the first step. You have a problem, or you have an opportunity to improve a situation. You create a conflict statement, and then you closely align as best you can that conflict statement with the 39 features of improvement. And when you do that, it's going to take you to the matrix, which is going to point you to 3 or 4 possible clues or inventive principles that might help you. And then hopefully you can get one of those to steer you in a direction for a solution. So here are the 39 principles, things that we would like to improve versus things that we don't want to compromise or we would like to maintain. And then you, when you have those aligned, you go to the matrix, and the matrix will point you to possible solutions to the issue, what you want to improve versus what you want to maintain. And then you drill down, you go to those principles of the 40 principles, and you put your detective hat on, and you get with yourself and your team members and you brainstorm a little bit. What is it saying? What are some clues here that might help us solve the problem? Okay, I'm going to move on to a real live processing problem, I call it, because I think TRIZ is excellent for process improvements, and I think it's excellent for product improvements. And first, we'll start with a processing improvement. The tolerance on bushing replacements is so tight to the housing diameter that it is extremely difficult to insert the steel bushings. Right here is the steel bushing. Okay, very difficult to seat into that housing. What we would like is we would like it easier to insert, but not at the expense of the size and the tolerance. Okay. So we're going to go to the 39 features of conflicts, and we're going to try to align our problem statement with the 39 features of conflict. And the best possible solution that I saw, and again, you may look at the problem differently, that's okay, is we want to improve the volume of the stationary object without compromising its shape. We want to improve the volume so we can seat it in there without compromising its shape, all right? Now here's where the automation takes place. Normally we would go to the TRIZ matrix to find our solution, but instead we're going to flip over to a website that's available to you, and I'm going to click on that right now. And it'll take just a second. And over here, thank you, Internet, somebody has automated this process for us. So the feature that we wanted to improve for the bushing was the volume of the stationary object, but not at the expense of, or what we wanted to maintain was its shape. And when you plug in those two features, it automatically populates over here on the left the 40 inventive principles that it's directing you to. So there's an automated way you don't have to wrestle with that matrix. The first one here is nested dowel, and I'm going to click on that, and you can see on this website it gives you what it's really trying to say, and it gives you some examples of how you might look at a possible solution. Again, you have to have your detective hat on here because it doesn't always jump right out at you. You might have to brainstorm it around a little bit, but this is giving you ideas. Now, in the interest of time, I'm not going to read through all of these. I'm just going to kind of click, and then here's another one. Number 2 is called taking out, and there's some more examples of what that means. Where I found the answer to this one is in a number 35 called parameter changes. And I read through these: change the object's physical state, example, gas to a liquid or liquid to a gas. And it tells you there how that can be done. But if that's not applicable, you keep moving down and keep moving down. And the last one here, we noticed that it was raising or lowering the temperature. And although it wasn't exactly applicable, it got us brainstorming about what if we raised or lowered the temperature. And we did a little research on that, and we discovered that lowering the temperature may provide a solution. So that solution came from number 35, parameter changes. I always encourage folks to document which conflicting features you used, in this case, volume of stationary object and shape, and which one it pointed it to that you found the solution, parameter changes. You should always document those because in a day or two or a week, you might not remember your thought train, your thought process that led you here, okay? So that's always good to document. Changing the temperature. So we're going to switch back there, and that was, in fact, the solution. Freeze the steel bushing with the liquid nitrogen so it shrinks before installation. The bushing will expand when it returns to room temperature. Again, that came from number 35, parameter changes. And I'm going to flip to a YouTube video to show you an example of this. It's going to take just a second here to come up. Liquid nitrogen shrink fitting. So there's the frozen bushing in the liquid nitrogen, and we can't see visibly, but it has shrunk because of the temperature. And it slides right into the bushing, right into the housing. And as it goes back to room temperature, it's going to grow back to its normal temperature state and seat right in that housing. So there's an example of a process-related problem that was addressed with TRIZ. I'm going to take just a quick second here to do a poll question. Do you think TRIZ can help your company with process improvement? Take just a minute here to jot an answer down. So I'm seeing on my screen 48% say yes, it can help us with process improvement, and 48% also said potentially, and only 4% said no. So it looks like it may be something that could be valuable to your process. Okay, we can close the poll at this time. All right. The next one I'd like to walk you through is a product-related TRIZ event. Again, the first was process. This is more of a product-related. And this is a tire here. And it's what we call a cut tire sample where you can see the construction. This yellow area here is the ply stock in a tire, okay? The thickness of rubber required to coat ply stock in a tire for desired performance characteristics is expensive and requires a long cure time, which reduces productivity and capacity, okay? What we would like is we would like to put less rubber coating in ply stock, but not at the expense of strength. Rubber compound is, depending on which compound it is, approximately $1 a pound. So when you're making a lot of tires, it's very, very, very expensive. Less rubber coating in ply stock, but not at the expense of strength. So we're going to now go to our 39 features of conflict. And the most likely lining up on the 39 features that I can see is we want to improve the weight of the moving object, but not at the expense of strength, okay? Improve the weight of the moving object, but not at the expense of strength. So again, using the automated system, we're going to click over to the website. And over here at the 39 features, we're going to plug in improving the weight of the moving object, but not at the expense of number 14, which is strength. And then it's going to auto-populate possible solutions. This example showed us 4 possible solutions. Then we put our detective hats on and we start analyzing the direction it's pointing us to. The first one is replace a mechanical means with a sensory, and the next one is use electric, magnetic, and electromagnetic fields to interact with the object. This is after some brainstorming where the solution came from. It actually came from the first one we analyzed. So in the interest of time, I won't go through the last 3. We did go through the last 3, but this looked like the most viable option here, using electromagnetic fields. So we brainstormed that and come up with processing the ply stock through a preliminary electromagnetic action using a surface precure unit. The electromagnetic action had a microwaving effect on the ply, on the rubber coating on the ply, and that enabled us to reduce the amount of rubber and cost without compromising any performance characteristics. The cost saving was so great that it outweighed adding a process step into the total process of making a tire because of the amount of rubber savings. On the left, you'll see a similar type of a unit that the ply was run through. And then again, on the right, you see the cut tire. So this solution here for the product came from the mechanics. And again, I always encourage you to jot down your thought process along the way. What features of conflict did you use, and where specifically did you get your solution? Here's another poll question here. Do you think TRIZ can help you improve your products? You just take a second and Mostly 44%. Yeah, okay, we're still entering. That's good. I'll give the folks just a second here. Okay, I think Amanda closed the poll. So we have about 40% of the folks say yes, it could potentially help us. And 48% said that it might help. 40% said yes, and 12% didn't think it could help their product. All right, very good. I'm going to run through just one more while I have the time. The problem statement: multiple complaints about gas caps. They're dirty. They make your hands smell like gasoline. It makes check engine light appear if they're not properly twisted on, and sometimes you forget to put them on. So what we would like is we want it easy to put gas in, but not at the expense of safety and functional ability. Kind of as close as I could think of as what we would really like to see. So we translated that conflict statement into the most likely features that we could align it with, which was we want to improve the affected harmful factors, the dirty hands, the smelly hands, the forgetting to put it on, without compromising the ease of operation. So then we go to our website again, and we plug in number 30, which is object affected harmful, and without compromising number 33, the ease of operation. And there it points us to 4 clues. The first one is called taking out. Separate an interfering part on or property from an object, and it gives you some examples of that. Again, in the interest of time, I'm not going to read all of these, but the next one here, called self-service, is where we found a clue that led to the solution. This is a clue. Now, this is just something that I wasn't involved in, but it was an example that was hanging out there. Make an object serve itself by performing auxiliary helpful functions. Make an object serve itself by performing auxiliary helpful functions. Again, you got to have your detective hat on. And it gives you some examples of that here. But that's where the main clue came from. So I'm going to flip back to the presentation, and you can see the gas cap was actually totally eliminated. So on a lot of the Ford models now, when you buy a new automobile, there is no gas cap. The tank serves itself by opening and closing when you go to put the gasoline in you stick the nozzle in there. So it just totally eliminated the gas cap. Again, you want to document your features and the solution of the inventive principle that you found it. Okay. Just while we have a minute, I'm going to go back to the website, and I'm going to share with you another aspect of it. In earlier slides, well, first I'm going to point out that some of the features, and this happens to be one of them I discovered, but there are a few combinations of features where there really is no solution. If you wanted to improve the area of the stationary object without compromising the volume of the stationary object, there really is no solution to that in the TRIZ database from the study of patents. Okay, so I wanted to make you aware you might occasionally run into that. If I run into that, what I would do then is I would modify my features of conflict and come up with a different combination where there are clues provided. Okay. The other thing on this website, I'm going to go to the menu here, and on the menu bar, it has the TRIZ 40 principles. Take a second here. Go back. Oh, sorry. I'm going to go to the TRIZ matrix. And the matrix I showed you earlier in the presentation that was very, very hard to see because there was so much data on it is provided on this website. It is here. Again, on the left, you see the 39 features to improve. And going across, they don't list them, but are the worsening features or the features to preserve, or the, again, you can see there are different wordings out there depending on the source of information you're using. But I did want you to know that the TRIZ matrix is also on this website. In addition to that, there's a lot of information available out there. If you YouTube TRIZ, you can see different examples of TRIZ projects. Some of them were used even beyond process improvement and product improvement. Some of the projects were used to help generate ideas for business strategy or improving sales strategies, etc. So there's the website, there's YouTube. Here are some books to look at. And then there's also a TRIZ journal out there, and that's the website which updates, gives you updates on TRIZ activities out there. Again, it translates into the theory of inventive problem solving, and it's some of the examples out there are kind of fun. Once you get used to it, it's pretty interesting to see how it helps you brainstorm and how it helps you come up with new ideas. We'd love to hear, if you start to use this, we'd love to hear about your success stories. And this is my business card. And of course, you have the Florida Makes website where you have it's available to contact us. But we would love to hear about your TRIZ successes. And now, Phil, I think we have some time for questions here before the end of the hour.
Yes, Dan, we do. Thank you very much. Thanks for the presentation, Dan. We do have a few questions. And as a reminder to the audience, our question pane is still available and open, so you may add additional questions at this point. But a question here is, it kind of relates to the polls that you conducted during the presentation. You know, it seemed like over 50% in both polls indicated that there was either, you know, people didn't think that there was a use for TRIZ, or potentially there may be, but they weren't really sure. Is there any way, you know, I guess the question is, how can we know if TRIZ will be useful? Is there anything that we could do, whether it's with our products or processes, or anything that would, you know, that we could use as a flag and say TRIZ is the way to go, or something like that?
I don't think, I guess that's a very good question, Phil. I don't know how you would know. You know, there's a lot of problem solving techniques out there that may or may not be effective. And I would just encourage people to give this a chance and know that the clues from the inventive principles that it points you to don't always jump off the page. That's why you have to be a little bit of a detective, and you have to do your due diligence on going through the clues. But again, back to the question, I don't really know how you can know if it's going to help you or not. before you try it. I do know that even beyond process and even beyond product improvement, other people are using it now for business strategy.
Okay, thanks. And the second question I have is about your work with TRIZ. You know, you showed us the several examples, and you know, when you started working with TRIZ, did you just pick it up? Did you have any formal training? Did you have a coach or a facilitator? Can you tell us a little bit about how you got involved in actually using TRIZ?
That's a good question. How I got involved with it was I had a coworker show it to me, and it took a while for me to warm up to it because I really didn't have an issue in front of me to try the process out on. So eventually, later in my career, I had some issues that I was very frustrated with. So I thought, well, maybe TRIZ can help, and that's where I had some success. Later on, I overheard a coworker with an issue, and it had to do with fitting components into a box build. So we used TRIZ to help us brainstorm solutions to that. And one of the solutions that it pointed us to was, can you turn objects upside down? And we actually turned some of the components upside down to fit them in the box build. So there was another example. Yeah, it's just when you're frustrated, okay, or you don't have a quick solution to it.
Right. Okay. All right. So, you know, in using TRIZ then as a problem-solving structure, that's comparable to you know, like a DMAIC or you know, the structure of a Kaizen. Is that right? And or can this be not substituted for, you know, some other problem-solving, but used in addition to?
That'd be my recommendation, Phil. It's another tool in your toolbox to give your company a competitive advantage. And I would recommend using it in addition to the known problem-solving techniques, the Kaizen process, the Six Sigma process, those types of the work simplification process, those types of things, in addition to, I think TRIZ can be a valuable asset.
All right, thanks, Dan. I have one last question here, unless we get a few others added in. But you talked about TRIZ in strategy development as an example. Do you have some specific examples, you know, for non-manufacturing types of improvements? Have you seen that? Have you been involved in any of that, or you know, do you know where we can get information about that?
I have not personally been involved in any TRIZ activities around that, but I have seen on the internet, for example, there's a couple of examples floating around out there where the TRIZ process led them to the development of jet sharing, like NetJets and Wheels Up and companies like that. They're used as examples from the TRIZ process.
Okay, would the TRIZ journal or one of those other references that you showed on that previous slide, could those be sources then for examples of people who've actually used TRIZ in other you know, in non-manufacturing areas?
Yes. Mm-hmm. The TRIZ journal highlights success stories and kind of chronicles some current activities around TRIZ.
Okay. Well, Dan, I think that about wraps up the questions that we have. I want to thank you again for the presentation today. And for all the participants on the call, as noted earlier, the recording of this webinar will be provided to everyone within a few days. I thank you all for attending today. As you exit the webinar, we ask that you please complete the survey that's presented. We're seeking your feedback about how to improve these webinars and to better meet your needs with topics of value to you. Thank you for attending today. Goodbye.